Okay, following on from my recent review on this meter, I'm going to do a teardown on it now. So if you're going to buy this, buy one of these for yourself, or if you've already got one and you're curious to know what's inside, or if you're just curious to know what's inside and what the build quality looks like, then this is probably the video for you. Obviously, if you do buy one of these, bear in mind the warranty will be void if you open it, and you know, I don't know how Keithley would react, but you know, there is a warranty sticker here. So anyway, I'll do it so you can get to see inside, save you from invalidating your own warranty. Right, let's reposition the camera and let's take it apart. Okay, so as we saw probably in the review, if you didn't see it, this just pulls off. I guess the rear boot also pulls off. Okay, what I think I'll do is I'll just remove these screws, and the whole thing should come off. It certainly doesn't feel glued, but it doesn't want to come off so easy. Okay, so the first thing to do when taking something apart that's got warranty on it is very carefully remove the tamper-proof seal in a way that you can put it back on. So there it is right there. Okay, so this is just a single screw, I think. Okay, let's have a look and see what we got. Okay, so let's have a look. So the first thing you'll note is the shielding. Now, if you remember when I'd done the test in the review, I did sort of say it was very, very low noise, and you know, that's certainly got something to do with it. So that's quite nice. At first glance, it actually looks really, really quite well made. It's quite solid. Now the GPIB interface is, we know, a module. It's an option, so let's just take that out. So that's just plugged in on that header there. Let's see what components we got on here. 75161. I'm pretty sure they're TTL buffers, which would make sense. I'm surprised they're using them old parts. Must be some characteristic about them. LVC 4245. Let me find out what that is. Okay, so the 75160 and 161, which are these two, are bidirectional bus transceivers with open circuit, open output capability. So that's obviously what's driving the 488 bus here. This chip here is an LVC, and this one here, the LVC 4245s. And what these are also bidirectional bus drivers, but also level translators. So I'm going to guess, and this chip here is a NAT 9914, which is an IEEE 488.2 controller. So I'm going to guess that's a 5-volt part, and the logic out here is probably 3.3 volts in the counter. So those are the level shift for the bus driver this way, and then these are the actual buffers for the output there. That's it. There's nothing else on there. There's a regulator. Bit of power supply circuitry. There's an oscillator here, crystal oscillator, and that's it. That's about the size of it. So it's a passive interface with that intelligent controller on it. Okay, so what else is in here? Let's take a look at this. Pull this shielding off and see what's underneath there. Oh. Lots of analog goodness. Right, let me get the camera in closer so we can take a closer look at what's inside here. Okay, so looking at the board here, this microcontroller here is an ARM7 chip. It's an LC2148 microcontroller. I can probably zoom in there. Sorry, I'll just take a look at that. Once the can't really get the right light on it. Let that settle. Hopefully the camera will define that. Yeah, so it's a LC2148. It's a 512K of flash and 32K of RAM. It's also got 8K of shared RAM between that and the USB port. So, given looking at the overall architecture of this, the USB port is down here, and this is obviously the main microcontroller. Being ARM7, you can see here there's an opto isolation, and there's a volt barrier here. So this is obviously the ground reference stuff. This is for your external connections and USB. This will be mains earth referenced, and then everything over here will be the actual meter itself communicating here. And by the looks of it, this over here is another microcontroller. Let's just figure out what that number is, if we can get to see it. It's running at 12 megahertz. I'm guessing it's a microcontroller because of the density of the pins and also the vicinity there. It would make sense that the main controller down here, or the controller for the USB at least, is communicating with another microcontroller. Let's have a look and see if we can find out what that part number is. Not sure I can get focused on here. Let me just LPC 2103, so that's another ARM part. Let me just go find out what that is. Yeah, that's also an ARM processor. It's 32K of flash and 8K of RAM. So that one, I guess, is the one that looks like it's going to control the metering, the analog to digital converter electronics here. Now let's see what else we can see on here. There's a lot of discrete logic chips and op amps, obviously analog circuitry. There's the now world famous LM399 voltage reference here with the loose temperature oven or temperature jacket, whatever you want to call it. Yeah, it's an ADS1271. It's 105,000 samples a second, 24-bit Delta Sigma ADC made by Burr Brown Texas Instruments. A very nice converter that is. Over here we've got most of this circuitry is just various op amps and filters, switches, some analog switching. This is a driver for the relays. It's a ULN 2003, I think. And this is a true RMS converter. It's an AD637 part, and then various supporting components around that. So not much there. Obviously over the input side here, let me just get the camera looking at this properly. You can see all the input protection, the MOVs, and the spark gap parts. You can see all the really nice high voltage routing cutouts on the board. It seems really well made. This actually, it seems quite nicely put together. So I guess possibly not in the same league as how they used to make them, but certainly really nice. I'm going to just take off this shielding. It's just held on by one spacer over here, and we can have a quick look underneath the board, see if there's anything else under there. Yeah, there's a small bunch of passive components, but nothing other than that, just sort of pretty much what you'd expect. No other components on the back there. Let's get this out of the way. Now, one of the things I was curious about, given there's two microcontrollers in here, I'll just put this handle off. Given there's two microcontrollers in here, I was wondering what the front panel, how the front panel is controlled, and I was looking at first of all this connector, but this looks like it's the connector for the thermocouple. If you remember, it's got a thermocouple connector here, which would make sense because that's going into the analog circuitry. But this control, this cable here would appear to be the front panel controller, and if you follow that round, that ends up on this socket here, which is wrapped around this earth guard, this ground guard here, which is actually part of the digital control circuitry. So that's the the architecture from what I can tell. Okay, I think what I'll do now is take the front panel off and see if we can see what chips are on there, see how that's made up. Okay, these are obviously just blanking plates, and this is designed to be rack mounted as well. Okay, that came off nice and easily. So the first thing to note in terms of build quality, again, you know, there's nice brass inserts in the plastic. So actually, they've done a pretty good job building this. It's really nicely put together. It feels really solid. And okay, so let's have a look. One of the things I was curious to know when I was looking at this display, I kept on looking and thinking, I wonder if they put a bezel in and just sort of change their mind at the last minute and put a crappy display in. But looking at this, I don't think that's what they've done. I think they've designed that from the ground up to be like that, which okay, anyway, let's I'm not sure it's actually worth taking this off, because there's really going to be nothing there. There's basically an LCD display. I suppose we could have a look at the crappy LCD display, not that that's going to get us very far. It's definitely part of the original design. They haven't done a fantastic job at cleaning up after themselves, so you know, that's obviously been hand soldered, and you know, there's still quite a lot of flux residue on there. Right, so let's have a look. So what have we got here? This is a Holtec HT1625. Let's I'm assuming that's just by the fan out here, that's just got to be an LCD driver. Let me just go and check. Yeah, okay, so that's an LCD controller, 64x8 LCD controller. This one is another microcontroller, which would make sense because there wasn't a large amount of wires coming to it. So this is a MC68HC908, which is an 8K flash 6800 series microcontroller, nothing special. So I guess what's happening here is that's dealing with keyboard scanning and communicating with the LCD display driver, and that's almost certainly a serial interface back to the main microcontroller, which is driving it. So that right there, in instrument terms, is kind of like a terminal: display, keyboard, serial. I guess it'd be quite entertaining to try and reverse engineer that and see what's going on. I also noticed here that as well as the it's slightly curious. I guess what's happening here, and this is a guess. If you look at this board, you'll see that there's a high voltage cutout here. And if you remember, I said there was that small cable which was going into the analog circuitry. But there's also these opto isolators taking this circuitry here, and that circuitry is just this temperature sensor, and bringing it across here. I find that's curious. That is, I have no idea what that's doing. So I can only assume that this microcontroller is dealing with doing the temperature, and this is bringing power up to power this circuitry, this side of those optos. Let me see if I can identify those optos. Maybe that'll shed some light on what's going on. Okay, so I decided to take this out because I was curious as to what was going on, and what I found is quite interesting. So if you look at this circuit, there's three optos, and the two are running in one direction and one is running in the other direction. You can tell that from the orientation of the parts. You've got these thermocouple connectors, and you've got this thing going off to the board, and I was trying to figure out, well, you know, these are not linear devices, so they have to be digital signals going across here. And that circuit at first glance didn't make sense until I had a look under here and got down and looked very, very closely. So if you look, I don't know how well you're going to be able to see this, but if you look, let's see how, if you look down in here, you can see just underneath there is actually a chip. So my guess is that's a thermocouple controller, and it's actually, that chip is thermally coupled to these two pieces of metal so that's so when the thermocouple plugs in, they make connections here, but the temperature of this metal here is actually reflected on the top of the chip. Now, the reason why that is the way that works is the nature of the thermocouple. It works by connecting two pieces of metal of differing types together, and that's not just true at the thermocouple end. There's a matching thermocouple at this end, and that needs to be compensated for. So the changing temperatures around here will change the reading of the thermocouple as well as changes in temperature at the other end. So that's what that's about. That chip there is sensing the temperature of this and compensating for the temperature changes of the actual units. And that would explain it, because that chip is then a serial device, and that serial device will be communicating. It looks like SPI, so it'll be a chip enable, probably a clock, and then data back. And so this microcontroller will just be reading it. And I suspect this, therefore, is just providing the power supply for that chip from the main electronics power supply. Yeah, so that's it. There for all to see is that really crappy LCD display. Yeah, I'm sorry to keep on going on about it, but it really bugs me. You know, they have such a nice bit of kit, and then they put that piece of crap in to show you the interface. Real shame. One other thing I found when I took off that board is, just as I was saying, they were doing a really nice job at putting these brass thermocouples in. They've decided then to save a bit of money and not bother putting them into here. So you're just back to self-tapping screws, just there into plastic, which I don't know. I'm not. It's a bit cheap. Again, a little bit cheapskate. They have gone to the trouble of putting a bit of glue on, which of course is no longer there. I'm not sure I've got any glue. I'll probably just tack a little bit of super glue on there just to re-establish that, because if you push these buttons hard, you could push the board away, I suppose, in theory, especially if I don't tighten these correctly and perhaps over tighten them. Anyway, that's that. As you can see from the plastic moulding, you know, I suspected it might have been that they kind of put a bigger bezel in to fit a smaller display in, but as you'll see, the letterbox opening cut out in the actual plastic is exactly the size of the display, so that's not the case at all. This thing was designed from the ground up with that crappy display. Okay, I'm not sure I'm going to achieve anything more by taking any more of this out. Just have a look at the mains wiring, which is actually, again, very good quality. You've got a very nice properly bonded earth, which is fantastic. I love to see that. Good high quality insulators over all the spade connectors here. Really nice wiring. They've paid attention to detail. You know, they've done this in a tidy way. This has not been thrown together. This has been put together properly. And you know, despite what the quality of the display might lead you to believe, there I go on about that display again. But despite the quality of the display and what that might lead you to believe, actually this meter is built really nicely, as far as I'm concerned. I can't fault it. You know, I won't say it again, but I'm going to say it again. Apart from the display, the rest of it is put together really nicely. Yeah, built solid. The soldering, you know, the quality of the soldering. I don't know. Let's see how we can get on that. Yeah, it's first class. Really, very good. So and it's made in Taiwan. Don't know if it says it on the back. Yeah, made in Taiwan. Yeah, made pretty well, I would say. Another thing they've done really well, I was just going to point out, if you look at the power switch here, it's actually on a plastic bar going back, and of course to a hard power switch in there. But something I really like, which you don't see done that often, is I don't know how easy it will be to see that, but that switch is actually on a small little subboard, and then the power connector is going to it. Now, that said, so the construction here is, you've got, because if you look, here's the hard switch, but if you look at the power switch, but if you look at the bottom, there's no mains on this, which is really nice, because you know, that can, and what I've seen in a lot of kit is they tend to put the power switch on the main board because it's a convenient way of mounting it, and then you tend to have this section of a board that's just got mains on it, and it's just, I I really don't like that. That sits really uncomfortable with me. I mean, I'm sure technically it's fine. It's just in principle it seems a bit wrong. Anyway, what they've done is they've put the switch onto a separate little board, and then they've mounted that board onto the main board using standoffs and plastic nylon spacers, which is really nice. Now, the downside, and where I think they've again, perhaps it's just saving a bit of money. It seems really odd. Is they haven't used the 2 poles of the switch. So the switch has got 2 poles on it, and they've probably just paralleled the poles and just they're switching the live. And of course, the live is the live until somebody wires it up wrong, and then it's the neutral, which means when you switch it off, at least that part of it remains live. Not necessarily a problem because this is all encased and it's it's safe enough. But it's just for the amount of effort it would have taken them to make that a 4-pin connector, in here, run another couple of wires and just isolated the mains fully. It just seems like after doing such a nice job all over the meter, everything's really built really nicely, and then they go and do things like that, and it just this is attention to detail. They certainly could have done a better job than that. All right, so let me go and I'll put this back together now and power it up and make sure it still works. One other thing I didn't point out here is on this board, right by each microcontroller, you can see that there's these headers here. These look like JTAG headers, so I guess these are programmed on some kind. The boards are pre-programmed probably on some kind of in place board mounting thing with all the test pins that just push up here, but. Obviously, if you wanted to hack this thing, not saying it would even be worth hacking, but if you wanted to, obviously you've got the JTAG headers here, and you can get access to both microcontrollers. One other thing that's probably worth pointing out: the construction of this meter. This is an aluminium outer sleeve, and they've folded there and riveted that. I actually really like this construction. Keithley do this, Agilent do this, or HP do this. Yeah, it's really nice. Aluminium. It's part of the reason why it's light, I guess. Okay, so all back in one piece. Let's see if it actually works again. Yeah, no problem. Okay, now I did draw a really basic architecture, and as you can see, I really threw it together very quickly. Not that it particularly matters. I thought it'd be worth looking at though, because just to remind ourselves. So we've got 2 microcontrollers here. We've got the main microcontroller, which is an LPC2148. That's quite a big micro. And that's communicating over serial to a small 68 HCO 908 microcontroller, which is mounted on the front panel. That's obviously controlling the display and the keypad. We've then got full opt isolation and digital communications over to this microcontroller, which is an LPC2103, and that's obviously amongst all the other things dealing with all the relay switching, all of the analog switching, the actual ADC as well, and then obviously all the analog circuitry and the input jacks. So that's the basic architecture of this. One of the things I'm quite surprised by this, well, I'm not sure I'm surprised or not, but Keithley and HP or Agilent both have patents and copyrights on, or I'm not sure the copyrights, but they've certainly got patents on various incarnations of multi-slope converters, which tend to be made up of some kind of custom logic and a bunch of analog op-amps and sample and hold circuits and that kind of stuff. And in this meter, they seem to have foregone all of that and just used a straight off-the-shelf part, an ADS1271. And I guess, I thought, well, that's a bit surprising at first, but I guess when it comes down to it, this is just more cost effective. I mean, this part probably costs $3, $4, $5, something like that. And it does the work of all of that stuff. If you look inside, an older meter, like the Keithley I've got up here, the 2015, there's an awful lot of electronics around doing that conversion. Right, so there you go. Hopefully you've found that useful. I've got the meter working again, so I haven't broken it. If you're going to buy one of those, or you were curious what's inside, obviously, if you're going to buy one of those, saves you taking it apart and voiding your warranty. Just talking about the warranty for a second, you will notice that the tamper-proof seal has been replaced intact. So hopefully, if Keithley ever get this meter back at some point in the future, they're not going to know this was the particular one that I tore down and had a look at. Right, that's it. If you enjoyed that video, if you found it useful or vaguely interesting, please give it a thumbs up. I've got no more puppies or anything like that, so it's not quite as interesting as the last video. But thanks very much for watching, and I'll catch you next time.